Today we're going to be talking about creating web visualizations with Trame, which is a fantastic new package from Kitware. Well, new, it's been around for about 3 or 4 years now. What is Trame? It's pronounced, by the way, as Trame because it's supposed to be a French word for frame or framework. So they created a new framework for web visualization. Trame is an open source platform for creating scientific web visualizations. It was created by Kitware. First release was in September 2021. It's actively updated, so now we are on version 3.10. And it provides a unified client-server model with a Python interface. Kitware is a company that provides a lot of open source software for scientific visualization. So they are the guys who created original VTK, the visualization toolkit library, and ParaView. And Trame provides widgets supporting not just VTK and ParaView, but many other plotting packages as well. So I'm going to show you lots and lots of examples today. So I personally started looking into Trame. I read about it over the past few years, but I really started diving in about 3 weeks ago to prepare for this webinar. I have no connection to Kitware, so everything I'm going to show you today, I learned mostly, well, 99%, I learned in the past few weeks, and some things don't work yet. So some things I'm still a little bit puzzled about, but yeah, hopefully I'll be able to share today things that work really well. So before this deep dive, so until a few weeks ago, I used to think of Trame as a way to write VTK.js, so JavaScript version of VTK, for in-browser visualization from Python. So not using JavaScript, but using Python and coding and essentially, producing a VTK.js application. But it's actually a lot more than that. So think of Trame as a server component web dashboard into which you can plug different visualization components. So it could be VTK, could be VTK.js. I'm going to talk about this in detail in a few slides. So you will, if you have no idea what VTK or VTK.js is, just bear with me. I'll explain in a few minutes. You can plug things like matplotlib scripts, plotly scripts, PyVTK, ParaView scripts, etc., etc. So functionality is really quite impressive. And the idea is that you do all of this via Python, and the Python script runs on the server backend. And then you also have an interactive graphical widget that is rendered either on the server and displayed in the browser, or it's rendered directly in your browser via VTK.js. So let's talk about the history of VTK, because it's quite important to understand the context before we start talking about Trame. So VTK is a visualization toolkit library that was started in the early 1990s, so it's been around for more than 30 years now. And originally it was a C++ library. It handles essentially, it's a library for computer graphics and visualization, primarily three-dimensional visualization, but you can do 1D and 2D visualization as well. So it handles data processing and rendering, has very rich pipeline with tons and tons of functionality, tons and tons of filters, and it handles I/O as well, in the sense that it provides very famous VTK file formats that we teach all the time in our visualization courses. Originally it was written in C++, so you actually had to code it, you had to code it from compiled language like C or C++ or maybe Fortran. And the interpreted interface layer in Python actually started, the development started in late 1990s, but for most time it was just very bare bones. But in the around 2010 or so, the development accelerated and they achieved full API coverage by 2018. So that means that now everything you could do originally in C++. VTK now you can actually do in Python VTK as well. And both C++ and Python VTK run on the server, in the sense that you run it on a machine and you get the results right on this machine. So you get rendering, you get visualization right on the same machine. So of course there is also ParaView that was built on top of VTK, right? So ParaView can run in client server mode, but we're not really going to talk much about ParaView today. So today we're going to be focusing mostly on VTK visualization. So originally C++ and later on a Python library. Then VTK.js is the rewrite of most of functionality on VTK in JavaScript. So the development started about 10 years ago, and first it was released in 2017. And the idea is that you can actually write the same VTK code you would normally write in C++ or in Python, but this time in JavaScript. It doesn't have full functionality of the original C++ VTK library, so it has somewhat limited processing and I/O. And also another limitation of VTK.js that it runs inside the web browser, right? So it's completely client-side. So that means that you can load an application written in VTK.js and JavaScript into your browser and then do visualization in the browser. But it's kind of limited, especially in terms of data processing, because everything is done inside the browser on the client side. So as of a few years ago, the state of the art of scientific visualization was that essentially you had to take one of two approaches. Either you work with, and I'm talking here about three-dimensional rich visualizations. Either you work with standalone VDK JS applications, so creating your websites writing web applications in JavaScript with VDK JS calls, and that way everything, all data processing, all rendering is happening on the client inside the browser. So you can write your own applications. It's completely open source. It's available to everybody. And you can also use prepackaged applications. So I like ParaView Glance. There's also ParaView Divi, which is a web, well, not web. It's kind of an analytics dashboard for the web. But I like ParaView Glance because it can import scenes rendered in ParaView and then visualize them through the web browser. So you can put your visualizations on the web. So here actually have an example that I show in my visualization courses. So if I click on it, let's say hopefully it works. So here is loading a visualization. As you can see here, we have a nice visualization with a lot of functionality, right? So this is very similar, to the GUI inside ParaView. And so here you can do quite a lot of things. You can turn on and off various layers. You can change colors, color maps, and various other things. So this is a pre-rendered scene in the sense that this scene was created in ParaView, exported as a, I can't remember the file format, but essentially it's a rendered scene. And now this rendered scene is, fixed polygons are being rendered inside the VTK JS application. So here you're limited, of course, to whatever you can do inside your web browser, right? So we're talking about standalone VTK.js applications. Alternatively, you can write a JavaScript application with VTK.js that will talk to a remote ParaView server. So this is the ParaView web framework. So this is a framework where you code in JavaScript and then somewhere on a remote machine, remote server, perhaps your departmental server, perhaps on an HPC cluster in parallel, you have a ParaView server running, and then your website is talking to this ParaView server, and all data processing and heavy rendering is happening in the remote system, and then you have a nice visualization on the web. So the downside of both of these approaches is that they rely, well, basically in both cases, you will have to create applications in JavaScript, right? And I know, JavaScript is quite popular in the commercial world, but I personally don't code in JavaScript, and I totally unfamiliar with JavaScript, so I won't be able to create these applications myself. And of course, it'll be very, very nice if you could actually achieve the same functionality with Python. This is where Trame comes in. So the whole idea of Trame is that it's a single Python application. So usually it's a Python, single file Python code that you run on the server. And the server could be on your own computer, could be somewhere on a cloud virtual machine, could be on an HPC cluster, et cetera, et cetera. You can also run it inside Jupyter. You can package it as a standalone desktop application. And basically, this application is responsible for two things. So it will do processing of data and rendering, perhaps will do rendering on the server side. And also creates a rich web UI application that is being displayed on the client side. So rendering can happen both on the server side and on the client side. But the nice thing about this approach is that everything is controlled by the same Python script. So there are some shared states. There are state variables, which are essentially a set of variables, a namespace in Python that is automatically synced between the backend, which is the server, the Python script, and then the front end UI, things happening on in the browser that you're interacting with. And so the state variables are synced, and that means that any change in a state variable, for example, you move a slider, changing the value of a variable inside the UI is going to be reflected automatically in on the server side, will be known immediately on the server side. And on the server side, you can create special callback functions that will do something, for example, can re-render your visualization based on the new value of that state variable. And also there are controller actions, which are special functions that are called from either Python, the main code running in the server, from the front end by various, like mouse clicks or selecting menu items, etc. And they can also be triggered by changes in the state variable. So we'll see many examples of these today. The documentation for Trame is actually quite good. So the front page contains a lot of examples. So if you click on it, it will take you to this website. And then if you go to examples and then you click on, let's say, this example, it gives you the source code. So it's a Python source code that will let you create this visualization, right? So everything is completely open. Also, there are some really nice examples inside the source code. So let me show you. Well, the source code is linked from the slides. So the slides will be shared later on today. I'm going to upload the slides to our website. But if you go to the source code, and actually I can show this in here. So Trame source, and then this is the repository behind it, right? So the same repository I'm showing here in the browser. And then inside the examples directory, you have a lot of really interesting examples. So some of them are with VTK, some of them with ParaView, some of them with somewhere in the subdirectories with matplotlib, et cetera, et cetera. An excellent starting point is probably if you just want to get started with Trame and you want to learn it quickly, then I would probably suggest not to look at the first at the online guides, but look at the tutorials, because it's a kind of a walkthrough guide that has lots of examples starting from the simplest ones, and I'm going to show you some examples from this tutorial today as well. The documentation is kind of bare bones. It's good, but it's kind of bare bones, so it doesn't really have tutorial style introductions, but it has full descriptions of all the the functions and the classes, etc., etc. And there is also a discussion forum that I linked from this page. So in the future, if you have any questions about Trame, this is the right place to ask these questions. So let's get started. Let me show you how we can install Trame. So depending on which component, so I mean, Trame has a modular architecture. So you can plug in components to do, let's say, VTK, Matplotlib, Plotly, VTK.js, ParaView, et cetera, et cetera. So depending on which functionality you need, you will install different components. So here you can install it with regular pip. In this case, I install it on my machine with UV. So the UV pip command. So here I'm creating a virtual environment that I'm going to load in a minute inside my terminal. And then here I install Trame core and then the UI. So Trame Beautify. Trame or Trame uses Beautify JS Vue.js library underneath for creating, the web widgets and the components. And then if you want, for example, to work with ParaView scenes, then you need to install this Trame components library. If you want to work with VTK, you need to install this guy. So this is mostly for VTK.js. This is to work with original VTK code. So the basic, the primary or the main VTK implementation in Python. If you want to plug in Matplotlib, you need to install these ones. If you want to plug in Plotly, you need to install this library and so on. So it's kind of obvious. And then if you want to run Trame inside Jupyter Notebooks, you can also add setup tools and then Jupyter Lab. And I'm not going to demo running Trame inside Jupyter Notebook, but essentially, instead of displaying in the web browser, your interactive visualizations will be displayed inside the Jupyter Notebook. And for development purposes, I mean, it's really great if you like Jupyter Notebooks. All right. So let's go to our first example. The first example actually just borrowed from the Trame tutorial, and it shows you how to create a layout. So here's, let me go back to the tutorial page, and then I'm going to show you the code for this. So the code is in this application. So as you can see, it's a Python application. It's entirely a Python application, and that's the entire code that I'm going to run in this example. So here what I'm doing importing is, remember that Trame has a server and a client. So the client is the web browser, and then the server is, the machine running this Python code that is talking to the client via WebSockets. And here we import a function from Trame main Trame library, get server function to create a server, and optionally, so this is an optional argument. So I think by default, still in many implementations, it's still Vue 2. So the previous version of the Vue.js library. So here, in most examples, I will be using version 3 of Vue.js, and that's how you tell the server that you're gonna use version 3 of the UI. And so here we basically have a function to create a handle for the server. We're not starting the server yet. And then we create a layout, right? So essentially here we create a user interface with a very, very simple call. So a single page layout will create a single single page layout on the website, into which we just place a single component. So we place a title, and that's it. And then we start the server. So there's not much there. So as you can see, layout is a handle. And what I'm saying here, while that handle exists, then I do something, I set the title or do some other things. So in order to run this, all I need to do is, of course, I need to source my Trame environment, so the library that I mentioned in the previous slide. So I installed it into these virtual environments. So bin activate, right? And then I'm going to say Python, and then I can just pass the name of the application, so the code that you see in the text editor on the left, to Python, and that's it. So, and if I do this, it will automatically open a website. So here you can see the whole page layout, and then there is a kind of a clickable button. So here it doesn't do anything because this is just a single page layout. But if you have more elements like a dashboard or dashboard, then that actually can turn the dashboard on and off. And then here we see the title, Hello Trame, right? So a very, very basic page. So optionally, you can, so by default, it's going to run on port 8080. But if you want to use another port, then you can just pass the -- port flag, for example, 1234 or whatever, and then it will use a specific port. So for example, here, let's start this on port 1234, and then it will automatically open the application on port 1234, as you can see. So if you don't want to automatically open this page in the browser, this website in the browser, then you can pass -- server, and that will simply run it as is. And then manually, I would have to open I will have to open localhost on port 8080, and then I will see my application. All right, so very easy. Let's change the single page layout to single page withdraw layout. So essentially, I'll need to insert these words before the function. So here I import the function. I'm going to import now a single page withdraw layout, and then here I'm going to say single page with draw layout, right? So I just changed the Python code, and then I'm going to rerun it like this. Okay, so let's see what happens. So now, as you can see, I have the drawer. So into the drawer, I can place various interactive elements like sliders, buttons, etc. And then presumably the main visualization will be happening on the right in the main window. And then I can collapse the drawer, right? So I can click on this button, and then I can turn it on and off. So there are several prepackaged layouts like this. I think we will see I will work mostly with a single page layout and a single page with drawer layout today. So let's add a simple Matplotlib widget to our website. So as you know, Matplotlib is a popular, I'm sure most of you know what it is, but it's just a popular library for creating static visualizations, right? So it was first released in 2003. So it's been around for more than 20 years. And I mean, it's really fantastic for, creating, all sorts of simple one-dimensional and two-dimensional plots. It can work in 3D as well, but its 3D functionality is very, very limited. So let's take a look at this code in this directory. I'm just going to copy this, and then I'm going to open this inside my my text editor. So here's the code, and you can see the code is very compact. And so this time, in addition to we import the usual things like get server from Trame, but we also import the Matplotlib widget. So here, this Matplotlib that I am clicking on, it's not the original Matplotlib library. It's a widget, right? So, and I place it into this namespace. I will call it Matplotlib. And then also we importing a pyplot from Matplotlib as PLT. So this is the usual standard Matplotlib library. And then also I import Beautify 3 as v3, and I can use it to have more control on the appearance of my widgets. And then what follows is a basic Matplotlib plot. So everybody, any of you who have programmed with Matplotlib, you will instantly recognize this plot. So it's the same code as you will see in normal Matplotlib. So here I just basically create the figure and the axis. The figure is of size 6, I guess, centimeters by 4 centimeters. And then I'll create a basic line plot, right? So here we have 4 points. These are the x coordinates and these are the y coordinates. And then I'm gonna plot these, mark these points with the dot, and then we'll connect them with lines. And then I place some text as well as label the x and y axis. So very standard Matplotlib code. And then I start the server for Trame, and then I create a single page layout. I put a title on top of this layout, and then with layout content. So this is the syntax you will see a lot today. I create a Matplotlib figure. So what this line does is essentially this Matplotlib is the widget, right? So here from Trame widgets is a widget. I create a widget into which I place my Matplotlib figure that I created earlier in this code, and that's it, right? So this v3b container, it's strictly speaking not really necessary. It's just there to make things a little bit appear a little bit nicer, and then give you a little bit more control over the how this widget appears on the website. And that's it. So let's try to run this. So I'm going to say Python, and then let's pass the same code to Python, and this is what it creates, right? So it's a random plot, and it has a line, right, and as well as the 4 dots that I mentioned earlier. So you can interact with it a little bit. There's not much interaction yet. So you can click on things like this. You can zoom in if you want, and then you can click on home. Will just take everything back to its original state. But we haven't coded any interaction yet. So if you're wondering about the what v3 container does and what kind of flags you can pass to this container, for nicer UI, there is a link to documentation inside Trame, and basically these are the variables, things like width, height, maximum width, depending on the browser, etc., etc. You can customize the appearance of the widget. All right, let's add a state variable. So a state variable is essentially a namespace where you store data that can change dynamically, and it is automatically synced between the Python on the backend on the server and then the front-end browser UI. And then you can watch for changes in the state variable. You can have many state variables. You can have just one. On the backend, using the add state change Python decorator. That will run a callback function. So a callback function is basically defined inside this decorator. And the way it works is first you need to create a variable. So here are the things we can add to our layout. So here I'm creating a slider. And essentially this slider introduces a new variable, wave number, which by default is going to have some default value. So this value is set in Python script, and then the slider will change from this minimum value to this maximum value, right? So it's an interactive slider on the website, and then with a step of 0.1, and several other variables to control the appearance of the slider. As well as we also place a button to reset the value of the wave number. So when we click on this button in the UI, the wave number is going to reset back to the default value. So the whole idea of the slider is that it introduces a new variable, wave number, which is a state variable that is synced between the client and the server. And the way we can access this variable on the server is through a callback function that is defined with this add state change decorator. So basically what it does, it looks for changes in the wave number. And as soon as it detected a change in the wave number, for example, we clicked on something or we moved the slider, then it will run this function inside this decorator, right? So it will run the function update plot that will take in the wave number, perhaps some other additional arguments, and then it will redraw our plot. So here we have the actually in the next slide we have the plot. You will see it when I show the entire code. And then we simply we change the scaling on the x-axis. So the number of picks on the sign function will change in the browser. And then so we change the data. Then we redraw the plot locally in Matplotlib, right? So we update the canvas in the figure. And then we run plot updates. Remember that, oh, actually, let me show you the code. So plot is the widget that I will create in this code. So let me show the code. So it's going to be line 2 in the same directory right here. So oops, hopefully it's not too small. So here we create the plot right here. So plot is our widget, right? So inside the container, we create a plot. This is our matplotlib code for this plot. And then we also have the slider and then the button, right, to reset the slider. And as you can see, the wave number is introduced by the slider. So whenever the wave number changes on the server side, this function will be run, and it will simply redraw the sine function, changing the wave number on the with the scaling on the x-axis. And that's it, right? So let's do this. Let's run this code. So I'm going to see Python 01, oh, sorry, 06 matplotlib, and then sine, what was called line 2 slider. And here we go. So here you see the slider. You see also this label wave number 1, and it's also present in the code. So here I pin the value of the wave number, the current wave number, into the web page. And notice that all of these elements are sitting inside the toolbar, so not inside the side drawer or inside the main page, but they are inside the toolbar, which is this big line at the top, big bar at the top of our website. And so here we're plotting the current value of the wave number, which is 1. And why this value? Well, here we're using default value, which is used throughout this application, right? So it's used to set the initial value of the slider, and then it's also used to reset my plot when I click on the reset button. So and then there is a spacer, right? So after the label, we'll have a spacer, which basically gives you a lot of empty space here. Then we have the slider, right? So we have the slider, and then we have the button. So let's change the slider. What will happen is, as you can see, it simply runs every time I move the slider, it runs the callback function, and it's happening in steps of 0.1 for the wave number. And then if I click on reset, it will simply reset this function, right? So everything is really very simple. And the nice thing is that everything is controlled. So we have a server, we have a client, but everything is controlled by the same simple Python application. So let me go to slightly more complex visualization. So this time, what I'm going to visualize, so this is a function, it's called a three-dimensional sine envelope function in a unit cube, and it's a function that I use a lot for teaching three-dimensional visualization. But basically, what I'm going to do here is it's a three-dimensional cube, and I want to animate the slice through this cube, changing the position of the slice inside matplotlib. And let me actually show quickly what it looks like. Let's see, I probably have a video just to show you what it looks like in ParaView. Slice, MKV. Oh, here it is. So this is what it looks like if you visualize this function, this slice in ParaView, right? But now I'll try to do the same in matplotlib, changing the position of the slide. So now I have a callback function that looks for changes in the slice, in the variable called slice. And of course, I will have a slider for that variable as well. And then if it detects a change on the server side, I mean, the change happens on the client side, that it's automatically synced with the server. And then either there's a change in this value of slice on the server side, then what it does, it simply takes my three-dimensional data and then creates a new two-dimensional slice out of it, right, at this position. And then it updates the matplotlib figure, and then it redraws the figure in the widget. So here's what the code looks like. It's, let's see, it's slice 2 streamline. So 6 slice 2 streamline.py, that's the entire code, right? So here I define my three-dimensional function. This is very familiar Python matplotlib call. I create a plot, right? So here I slice, at this default value of slice, which is equal to 30. And then I have a slider, I have a label, and I have a button to reset my slice, right? So if I look at the slice variable, then the slice variable, as you can see, it's being used as input to the callback function to redraw the page whenever there is a change in the slice value. And also it's used, first it was introduced by the slider, and it's also shown in the label, as well as I use it in the button to reset the slice to default value. And then here we simply draw the plot, and then the container here explicitly, just as an example, I show how you can set the width and the height, etc. So let's run this function. That's the entire single-page Python code, and as you can see, we have a slider, right? So now this mimics slicing at different values along the Z coordinate, and it's updated continuously. So whenever I don't even have to release the slider. So if I move the slider, then it's constantly being redrawn. And if you have a complex visualization that actually heavy and does quite a lot of data manipulation and requires quite a lot of data manipulation or rendering on the server side, so you might ask, what will happen if I continuously change things here and doesn't slow down the service? So the answer is no. So as soon as you have a new value of the slice, the server will start processing the new value. It will just abandon processing of the previous value. And of course, if I click on the reset, then it will just it'll just reset the value back to the original value of 30. Okay. So you can also very easily integrate Plotly, which is similar to Matplotlib, except that it creates interactive visualization, right? So it's a very popular package that is open source, and you can use it to create interactive visualizations. And you can with Trame, you can easily plug these into Trame dashboards. So here's an example of a code. Let's just take a look at this code. So let me show this code inside the browser. Oops. Inside the text editor. So here what we're doing is we have a single wave number slider. So right here. And essentially everything is very similar to the previous example, except that now instead of running the example 2 examples ago, right? So the sine function, except that now instead of running Matplotlib, I'm running a Plotly code. So here, as you can see, I import the graph objects as Go library. So that's the usual way of doing Plotly plots. And then I also import the Plotly widget from Trame widget. So that's I use this widget to place the Plotly plot into my dashboard. And then here I basically create a sine function, right? So here I create a figure of the sine function, which has the default wave number of 1. And then in order to update it, all I need to do is just run these callback function, and then I redraw my plot. So let's run this. So here we go. And then as you can see now, I didn't program a button here, just a slider. And as you can see, it works really well. So now let me show you an example where you can have 2 sliders. So I have now 2 variables that are inside the state namespace. So I can change one of these variables or both of them at the same time. So the code for this is actually right here. So let me show the code. Oops. Right here. And here essentially have 2 sliders. One defines a wave number. The other one defines an amplitude. And then there is a single callback function that redraws my plot if it detects a change in either of these 2 variables, right? So the same callback function works for both variables, for both sliders. So let me run this. Here we go. Now we have the wave number, traditional wave number, and also we have the amplitude. So that's the scale on the vertical axis. And as you can see, both of them work, just a single callback function for both variables. So in this example, I simply move both sliders to the side drawer. So notice that here, the sliders in the previous example, the sliders exist inside the toolbar at the top of my application. But of course, I can move them to the top. To the side with this syntax. Oops, I wanted to show you the file first. So here my sliders are now inside the drawer, right? So I created a layout, then I create a drawer, set its width, and then I place the sliders, the 2 sliders inside the side drawer. And when you run it, this is what it looks like, right? So the same functionality, the same application. It's just the 2 sliders are on the side. And finally, let me show you the last example, which is a lot more complex. So here I have 4 visualizations on the same website, on the same dashboard. So basically, I create 4 separate plotly figures. One of them is actually an interactive 3-dimensional plot. I have 2 callback functions, so you will see when I run it, you will see why I have 2 callback, functions. So the example is this one. Okay. So here I have a single callback function to create to look for changes in the wave number and the amplitude, and these update figure 1 and figure 4, right? So whenever I change the slider for the wave number, they change the and the amplitude. These 2 sliders change figures 1 and 4. Also, I have a parametric plot, which is a regular plotly 3-dimensional, interactive plot that is not controlled by any slider. Right? I just do, the usual mouse, rotation and the scroll wheel to zoom in and out. And then here I have a slider that controls the slides, right? So the previous application you saw in Matplotlib. So here basically I use the third slicer to update figure 3. So I have 2 callback functions, one for figure 1 and figure 4, and one for figure 3. So really easy. I won't show the application, but if you're curious, you can certainly send me an email, and I'll be happy to email it to you. There's a question: what are the functionalities that only Trame can offer and Plotly cannot offer? So so I'll answer this after because I don't have a lot of time, and I really want to dive into more complex examples with VTK. I will answer this at the end of this webinar. So VTK is, as you know, as I mentioned before, it's a library for doing 3-dimensional visualization, and you can integrate it into Trame in several different ways. You can do it with VTK.js only on the client side. You can have a hybrid mode where some processing VTK is done on the server and some processing is done on the client side. And then you can do entire pipeline, data processing and rendering entirely on the server. So here's an example with VTK.js only. So here we don't have any traditional Python VTK code at all. So let me show you what this example looks like inside my text editor. So here's the code. And in this code, I import the VTK widget from Trame widgets. And this is just an adapter to present VTK objects to the UI. So it doesn't really have the full VTK functionality, but it's still great for many different types of objects. And then here inside the layout, so I have inside the layout, I have a slider which changes the resolution of the cone. And then I create a cone object right here, right? So there are several layers of abstractions that are required in VTK.js. So essentially, these call to the VTK view provides a WebGL rendering canvas, right? So a canvas, something like an X11, for example, for a local application will provide. So you need a canvas for rendering. And then with VTK geometry representation, you can place various algorithms into this canvas, and then you call VTK algorithm to call from VTK.js. So this actually calls the JavaScript underneath. So you call VTK cone source from VTK. And notice here that the state variable is actually, there's no explicit callback function. So the state variable is actually integrated into these function calls. So whenever there's a change in resolution that is detected from the slider, then it will be reflected in the visualization. So let's run this. So I'm going to run this application. I'm actually running way behind, I noticed, so I'll try to speed up a little bit. So as you can see, it works, right? So here we have a nice application, a cone at default resolution, and then you can change this resolution by using the slider. And here it's done without the callback function. All right, so here's an example of VTK rendering where we use the full familiar traditional Python VTK pipeline. So basically, whether coding in C++ or in Python, in order to create a visualization in VTK, so now we're talking about the traditional VTK library, you create a renderer, then a render window, then you link them together by adding the renderer to the render window. You create an interactor, which provides a platform-independent interaction mechanism for various events in the GUI, connected to the render window, and it shows tracks the camera. You create a source, for example, a cone or cylinder, whatever. You create a mapper, which is a graphical representation, and set the cone source as its input. You create an actor and assign the mapper to it. You add the actor to the renderer, and then you set the camera to frame the scene, right? So easy peasy. So just a few dozen of steps, and you'll have your visualization in wherever you're creating your visualization. So this is the traditional pipeline, and you can actually run the same pipeline, from the same Python code that will then place that traditional VK rendered object into a Trame widget. So here's a code that shows how to do this. And here actually I took an example from the tutorial, and then I created two objects. So I have a cone and a cylinder. As you can see, there are lots of calls here. Actually, to make it more compact, I even placed several commands into a single line, so that you can see everything on the same screen. But essentially, I go through this pipeline that I just briefly mentioned in this slide, and then I create a cone object, and then a cylinder object through the active representations, and then I place them into the scene, into the renderer, into the scene, and then I visualize them locally inside the web browser. So let's run this. Oops, sorry. I need to call it with Python to actually run it. So here we go. As you can see, there are no sliders, no other interaction. Then you just rotating that or zooming in and out. So you can see there is a cone and there is a cylinder. So the nice thing is that here you have a choice between a local renderer and a remote renderer. So a local renderer actually runs inside, it's local to your client, right? So it runs inside the client. So here, when I do this, I do this interaction, it actually runs inside the web browser, right? So everything is really, really, fast. And what's happening here is that these objects, VDK objects, are created on the server side. And then the server sends via, I don't know, some WebSocket call, it sends the geometry for this to the client. And rendering is actually done inside VDK.js on the client. So that's what local rendering is. And it's really, really, on my side, not sure maybe there's a delay through Zoom, but in my side, it's really, instantaneous. It's very high resolution because you are just, you're sending the mesh, the geometry, which is not approximate, it's exact, to the client, and then the client does the rendering locally. So alternatively, you can switch to remote rendering. So here, all you need to do is just, instead of calling VDK local view, you call VDK remote view. And now when I rerun this application, let me actually close all these windows. When you rerun the application, now we have a remote view. And now what's happening is all rendering is done on the server, right? On the server, so basically on the same machine that runs my Python code. And then it's now a little bit more sluggish. So here I'm doing rendering, so generating images on the server. And then I'm sending these images via WebSockets to my client. Right, so now it's I see a little bit delay even on my side because now it's approximate, so it's a pixelized image, and of course sending an image takes a lot more bandwidth than sending the the geometry for several primitive objects. So here's an example that renders a VDK data set from a file. So let me show you. Actually, let me run this example because I don't have a lot of time and I still want to show you a lot of stuff. So let me just show you an example. So this is the same sum envelope function that I talked about before. And here I create a contour, and I do all of this through the traditional VDK pipeline, right? So I create an actor, a mapper, I place the actor into the scene, and so on. So, and then I have a nice visualization. Actually, I have two layers here. So I have the outline of the box, and then I have the contour, right? So which creates an isosurface. So let me actually add an interactive element to this. So I will add a slider and then a callback function to change the value of this variable contour value. So let me quickly show you the code behind this. So here's the code. Now it's because I'm using traditional VDK. Now it's a little bit more verbose. There's quite a lot of stuff there. But the interactive things are this, and then what's happening in the UI, and then the callback function. So as you can see in the UI, I have a slider for contour value, which has some default value, and then the default value set right here inside my Python code, and then I have a callback function that is triggered every time I change this value, and all it does, it simply updates the contour, and then it updates the view. So let me run this. So here we have a slider, and the slider simply updates the value whenever I change the value of the isosurface value, right, through which the isosurface is drawn. As you can see, everything is really fully interactive and displays very nicely. So in this case, I opted for the local view, so sending the geometry from the server to the browser, and then doing all rendering inside the browser via VDK.js. So controller actions are explicit functions that can be called from Python or from the front-end UI. For example, you can click on a button, or also from state changes. Whenever a change in the state variable is detected, you can also call a one of these controller actions. And here's a very simple example that just demos. It shows how we can do this. So here I have a button that whenever I click this button, it will explicitly call this the function called printout. Actually, printout is not the name of the function, but it's what the function is known to Trame inside the control namespace, right? And basically, every time I click this function, it will run this function. Will just print another line inside, well, on the server side, and then that's the way to call this not from not from a not from not linked to I, but just directly from the Python code. So let's quickly run this. So here I'm going to run the O3 HTML and then click .py. And then notice that here it gives me the print button. And then every time I click it twice, every time I click the print button, it'll just gives you this message on the terminal on the server side. So essential controller actions are explicit functions that you define with add control add directive, or whatever it's called in Python, and then it runs this function, and then you can have fairly rich functionality there. So let me show you an example of a complex VDK plus Trame application. So this application in Python code, again, it's like any Trame application, it's just a single Python script. But this particular example is more, in its original form, it was more than 500 pages, 500 pages, 500 lines long, not pages, 500 lines long. But let me just run it quickly, and then you'll see what's happening on the client. So here it renders a data set. So it reads this data set. This is from the traditional data set from the VDK tutorials. And essentially what's happening here is that it has this nice UI where it creates an entire visualization pipeline in the drawer, right? So here we have the drawer, and we have a couple of UI cards. So these UI cards are programmed using viewify UI card function calls. And there is a mesh, and then there is a counter. So you can turn them on and off, but then you can actually click on individual ones and have more properties for this. And so these, that's actually a nice example. It's quite complex. I won't show you the code. It's more than 500 pages long. 500 lines long, but not pages, but lines. But it actually, if you go through this in detail, you'll have a nice example of how to use calls to beautify the column and beautify the row to arrange all these elements nicely inside the drawer. But here, as you can see, I can change, let's say I can switch to contouring by velocity. Let me turn off the outer mesh, and then here I have a slider for the value of the velocity. And here, as you can see, I got a very nice visualization. So this is very similar to the type of visualization you will do in a ParaView, standalone ParaView. But all of this is done with Trame from scratch. So you can also plug ParaView visualizations so there is a ParaView, essential ParaView widget. By the way you run it is different from previous examples, because in order to run any ParaView Python code, you cannot just use a third-party Python installation. You need to use the ParaView Python, so PV Python or PV PV Batch, for example, launcher that comes with ParaView itself. So this PV Python comes with ParaView itself, but then you can point it to your Trame virtual environment using this -- environment variable. So here I have a code. I'm going to show you the text of this code inside my editor. So right here. And what it does, it just basically creates a simple cone, and then it has a slider for the resolution of this cone. It has a reset button, and then essentially, whenever I click reset button, it runs this update cone function, right? So it's a callback function, and then the entire visualization was actually created by this this very simple code right here. And those of you who have coded previously in ParaView Python, you might actually recognize this line. So this is a much more concise way to create all these objects and all nice visualizations as compared to VDK, right? So VDK is the original implementation. So ParaView Python is a lot more concise way of doing the same things. And the nice thing, you can actually plug these visualizations very easily into Trame, into Trame dashboards. So let me run this. Oops. Oh yeah, of course. I need to start it like this. So I'll need to use PV Python, not the original Python, and then I need to point it to my virtual environment where I installed Trame. All right, so here we go, and here I have a nice cone, and then I can update its resolution, or I can reset its resolution. Right. So here we go. But the nice thing here is that the code is even simpler than the previous VDK examples. And then, of course, if you want to create more complex visualizations, then you can use Preview Python scripting. It's very easy to get started with it. So there is a wonderful trace tool inside Preview GUI that lets you convert any visualization into a Python script, and then you can just use that Python script in combination with the Preview Tram widget in order to put a visualization inside the Tram web dashboard. So here's another example that loads a file from the command line. But actually, because I don't have a lot of time, I will skip this and I will go to the next one where I upload a state file. So I'm going to run this application instead. I'm going to just copy. So I'm going to run application upload state file. And what it does is, you will see in a second. So here we have a button to upload a state file. And previously I created a visualization Preview. I was kind of hoping to do it live, but because we don't have a lot of time, I'll just use a pre-canned version. So I created a Preview visualization in my local Preview client, and then I saved it as a Preview state file. And then I'm going to upload the state file to, it's right here, it's called demo PVSM. So PVSM stands for Preview State Machine. So basically it's a snapshot of Preview visualization. And then I'm going to open it. And then it's going to create a visualization, right? So this visualization I created yesterday, and then I saved it as a state file. And what it did, it simply I simply uploaded this visualization to a file. Sorry, to the dashboard, to the Tram application. Then it read that file, and then it saw that inside this Preview state file, I'm loading a data file. So the question is where this original data file is sitting. Well, it has to sit on the server because the data processing is happening on the server, on the Preview server, on the same machine where your Tram server is running, right? Yeah, and then you can include any complex visualize any complex Preview visualization via a state file this way. So a FlashArray demo, and this is something I was kind of hoping to do, but I ran out of time preparing for this webinar, is to upload both the state file and the data file. And it's possible to do it. It's quite easy to do, but it'll just, will require a little bit more coding. And in this case, you'll have a completely standalone Tram application where everybody, in the world, if you put it online, this application online, everybody in the world can just go there and upload their data file and upload their state file, and it'll just create a visualization, right? So just a much flashier demo. So I can also run Tram. Actually, yeah, let me, this will probably take a minute. I will show a demo on my phone. So what I'm going to do is I will go into I will log into a virtual machine that I'm running on Cedar Cloud. And then on this virtual machine, I'm going to, so I also have Tram installed there. So I'm going to go into the tutorial, and then I'm going to run this application. And notice that here there are a few additional things. So mostly the most important thing is that basically this setting makes sure that anybody from outside can go and connect to the port where this application is being served, right? So if you don't have this option, then it's only limited to a local browser. So in this case, by specifying that the host is 0000, I make sure that any external browser can view whatever I'm serving on that port 808080 on the server. So let me run this line, but actually going to move this out because I don't want to show the IP address, and I don't want to do this because I just want to make sure that I'm the only person who can connect to this server. So I'll talk about multi-client in a minute. Okay, so now it works. So now I connected to this port on the virtual machine, and here I have the full application running, right? So here I actually have the full application, and then I can play with the UI cards. So I can go and change, let's say, turn off the mesh, and then go to the contour and change the contouring by velocity, turn off the site UI, and here I have the full interactive visualization. Okay, so you might ask, well, all this is great, but how do you serve multiple users from the same server? So the idea is that in order to scale to multiple users in a production environment, you need a setup that isolates user sessions while allowing a single server process, a single Trame process, to handle all incoming connections. And the way it used to be done, you actually see these, let's see, when I start an example, one of the previous examples, it gives you this message right here. Know that for multi-users, you need to use and configure a launcher. And apparently this is something that was available in the previous version of Trame. And my understanding, I'm not 100% sure, but my understanding is that they discontinued, so they no longer allowed. So basically the way you configure a multi-user session or environment is you have to use third-party tools. And apparently, so I went to the forum, and apparently there are different ways of doing this. So not being a web developer, I don't really know how to do this, but apparently this is fairly standard practice for making sure you have, multiple users being able to connect to the same server session. And yeah, apparently it's not that difficult, but I don't know how to do this. So as you can see, Trame is really a fantastic application. It gives you, very simple way to create fairly complex applications, fairly complex visualizations in the web browser using just a single Python code. And then into this code, you plug in different widgets, different components, depending on how exactly you do this visualization, whether it's Matplotlib, Plotly, or VTK, or VTK.js, or ParaView, or PyVTK, or something else. So Kitware has actually an implementation of the full visualizer. So visualizer is a ParaView web application that you interact with through your browser, but actually talks to a remote server. And apparently, Kitware folks implemented this application in Trame as well, but it's not available as open source. So you need to reach out to Kitware. I did not, so I have not played with it. But the point here is that Trame is so powerful that you can actually easily, in a single Python application, you can recreate the entire ParaView as through a web UI, with all the nice sliders, filters, etc., etc. So I think what I'm going to do is I'll just put this summary and then open the floor for questions. So there are several videos for watching, with various Trame tutorials. So the one that I found the most useful is this one. So 3 years ago, in October 2022, there was a internal Kitware developers course, onboarding developers with Trame, and they recorded it, and it's a 2-hour video, but I found it's on Vimeo, but it's open to anybody, and I found that this video is really good, so it was probably the most helpful to me while preparing for this webinar.